What's up, everybody? Yeah, what's up, everybody? I'm about to start coding. I think my time is not set correct on my computer, so oh, I should get rid of it. Or better yet, I should move it to the other screen. Okay, great. Um, my system time is not set up correctly, so I'm just gonna change that. Okay, all right. Let's see. How do I change the time? Yeah, it's 2 hours behind. So there you go. I don't know why it was like that. I don't know because it was set to set the time automatically, but it was behind by 2 hours. So um, wow, that means because yesterday I was working on this time. I mean, I was using this laptop clock to know what time it is throughout the day. So I guess I was 2 hours behind the whole time. Alright. Let's just get rid of that. Wait, what? Why is my YouTube like that? Not YouTube. I meant my browser. It's not supposed to be wide, but I think I know why it's wide because I recently installed a virtual computer on my system, virtual Ubuntu, and I logged in through synced my account with that browser, and that browser had a white background and stuff. So I think that's what happened. I'm not sure. Although I think if I had you know, a customized setting here, it should have carried. The other browser should have gotten it, but I guess not. It is what it is. Yeah, I'll change it by some other time. Okay, so this is what I'm gonna be doing. I have RedNote. This is RedNote. I'm gonna be working on it today. It's a visual cryptocurrency and ecosystem created for learning and demonstration purposes. So currently, what's going on here is I have a couple repositories. So one, two, three, four, five, six, seven. But actually it's six repositories. The backend website, the front end website, the a Python script that automates stuff, a miner, which is a desktop application written in C++, and what is this? Oh, and the actual blockchain. So yeah, written in TypeScript, by the way. So well, everything is written in TypeScript. JavaScript, don't use that. I don't think anyone uses JavaScript anymore nowadays. Uh, Although I'm sure there's some people who do. Okay, let's just see something. All right, great. So I just want to check the memory because I'm recording. I hope. Yeah. Okay. All right. Uh. Okay. Awesome. Okay. Yeah. So basically, that's what I'm gonna do. I'm gonna open up Visual Studio Code, and as soon as it loads, I'm gonna start using it. I don't know why it's taking so long to load up. I don't know why. By the way, I recently upgraded my RAM. Um, Recently upgraded my RAM from 8 gigabyte laptop to basically a 20 gigabyte because I replaced one 4 gigabyte RAM. I had two 4 gigabyte RAM sticks. Now I have one 4 gigabyte RAM stick and a 16 gigabyte RAM stick. So that takes the tally up to 20. All right. So here are the repositories that I showed you in the GitHub on GitHub. These are all private, by the way, so you cannot find them. Although you can visit the link, you'll see the repo. I think not repo, the I don't know. What is this? The organization. Gee, I haven't coded in such a long time. It's crazy. I haven't really been on GitHub. If you check it out here, let me just show you my profile. Yeah, so as you can see, I've been, a little bit productive during the year. Last year January came, wasn't, a little bit February, next March really nothing, April nothing. It's only for the past 2 days where I've actually written code. So it's gonna be the third day. Oh, is it? Oh yeah, it's gonna be the third day today. All right, so I'm not sure if my font is big enough. Yeah, I think you guys can see that. I'm working on a freaking desktop computer, so maybe that's why. Okay, I think it's big enough. Okay, I think it's big enough. You guys can see that. So okay, we have updates. Okay, cool. All right. So this is my Python application. It's the automator. I have a main.py file. What else do I have? I have a folder transactions. I feel like okay, I have a folder transactions. My desk is in this. I'm probably gonna lose frames for not having my adapter charger plugged into my laptop, so I'm just gonna plug it in. Okay, so I have transactions, the transaction folder. Um, it has a main.py. Listen, guys, I haven't worked on this project in such a long time that I basically forgot absolutely everything about it. Let me give you the rundown on what it is. It's as we read in the GitHub repository, GitHub organization. It's a virtual cryptocurrency and ecosystem created for learning and demonstration purposes. So by no means is this blockchain going to be, or blockchain ecosystem going to be used commercially at all. No, but I will host it up on the internet. So if you guys decide to break it, you guys decide to break it. If you guys decide to hack it and have $1 billion in your account, you guys decide to do that. Okay, so basically, it's a whole ecosystem. I'm gonna have the website running, I'm gonna have the automator running, and I'm gonna have the miner that you're free to download on the internet for you to, mine virtually, I guess. Because yeah. So the automator, what the automator is gonna do is it's a Python script, so I'm creating 100 randomly generated accounts, and they're just gonna be like mining. It's kind of like you have a mining application, like yeah, like Bitcoin mining application on your desktop that you downloaded. So you have that, and you're using it to mine Bitcoin, right? Or mine whatever cryptocurrency you want to mine. And you're mining and stuff, and then yeah, and then you get a reward, right? So Node Automator is just a Python script that imitates that, but virtually, and it makes it seem like 100 people are mining all at once. So yeah, these are just demo created accounts that are created by Python uh, with fake names and fake email addresses, and they're just mining. So they're gonna just call the API. So by the way, the random blockchain. Yeah, by the way, you can see that. Okay, so the random blockchain is a centralized. Yeah, it's supposed to be decentralized, but it's actually centralized. Because yeah, I don't yet know how to really build a decentralized application because you need you need networking um knowledge to do that. So I don't really have networking knowledge. Anyway, so this is the blockchain I created it. It works. It works pretty okay. Right? It works pretty okay. So, and then this is the desktop application, and then yeah, so it's just 100 different people mining, and you can join them by downloading this application, and you also mine if you want to mine. Yeah, but on the application on the website, I'm just gonna make it possible that you can. I'm not gonna obviously not gonna allow people to insert their credit cards, bank cards, and stuff. I'm just gonna let uh, you know, like insert fake cards, fake bank card numbers or something like that. And then you're just gonna be able to add your bank card, fake bank card, and with that you're gonna be able to add funds to your account. And with those funds, just like Coinbase, with those funds you're gonna be able to purchase a cryptocurrency, and you're gonna be able to trade it basically. So it's a trading platform. Yeah, a crypto exchange platform to buy, sell, and trade Randall. It also serves as an official Randall website. So it's yeah, so it's just all in one. And then this is the back end of the website. Um, I forgot why I separated them. I think I had problems somewhere somehow, but yeah. So fine. And then Randall Rusty. This was actually supposed to be the actual blockchain that I was gonna use build after I built the Renault blockchain in TypeScript. So, but I'm not gonna do this. I've had enough of this project. I've coded a fair amount of it, so I just want to get it done and work on my other projects because I've been procrastinating for the past couple of months. So yeah, I want to be back. I'm back at it now. So this is what I'm gonna do. So I have earphones in my ear because while I'm working, there are gonna be extended periods of time whereby I'm not speaking. I'm just listening to music. Yeah, so that's gonna be it, basically. Okay, cool. Um, all right, all right, great. All right, so all right, great. So let's just see what we have here. All right, so this is the Landlord Automata. We have transactions. In transactions, we have member pi. Outside of that, minings, we have this the mining script for the Python mining, and then the database. Great! I just showed you guys my freaking database passwords and stuff. So yeah, it actually doesn't matter. Okay, so this is the password that I'm using for the database. It's a MySQL database that I'm gonna put on the server. Obviously, when I upload the information to the data, upload this application to the internet, I'm gonna use a separate database, different password for the database. Yeah, and I'm not gonna use. I'm gonna change. I'm gonna change everything, so you guys don't need to get worried about that. By the time the application is live, so let's see. I'm still trying to study the project structure and the application. Um, okay, I remember this was the script that I wrote. So this is basically disconnected from the actual application. This is just the file that is the name generator. So it just creates a file and this will just generate a bunch of names. So let's just see. I want to see the intro. Oh, and by the way, if I go back, okay. So I should probably open GitBash just to show you guys the actual project structure or folder structure. So, okay, so if I do this, in my projects folder, project directory, I have these stuff, but this is what we're gonna cd into rand node, right? So I'm just gonna cd into rand. Mm, can't type when people are looking at me. In this case, the camera. So I'm in the rand node directory. So this is what's in the rand node directory. Rand node automator, rand node exchange backend, and server blockchain. Great. So there are four applications. So usually when I work, sometimes I work on two applications at once. I usually when I'm working on the front end, I have the front end running and the back end running. I'm pretty much done with the server blockchain. Um, I would say, I would say I'm done with it, but it might need a little bit of administration, but I think I'm pretty much done with it. I'm just gonna open another GitBash here, please. Also, I'm used to working on Linux, Ubuntu. Oh, projects. Oh, brand note. I can't type today. I feel like every time I have to type and people are looking at me, I just can't, even though I'm alone today. But I just, I, there's, I feel the pressure. Anyway, so I'm just gonna see into, what am I gonna do? I'm gonna work on, I think, okay, so let me just run the blockchain first. I'm just gonna, the last time I ran this application, it did work. Oh man, I'm working on Windows. I'm working on freaking Windows, dude. I just got like, I just had a moment of realization where I'm realizing that a lot of the things that I'm doing, I'm like, I write a lot of my code on Ubuntu, so I have a desktop that runs Ubuntu, so that's where I spend most of my time coding. So now I'm on Windows on my laptop, so things are different. Okay, so let's just see. I'm just Alright, I'm just gonna close that for now because I don't know what's going on. There's so many problems with this ecosystem. So I'm just basically trying to clean things up now. So the server blockchain. So we have an index.ts TypeScript file. This is the actual server page. Nothing much going on there. Let's see. Oh, okay. So wait, there's a database. Wait, is there a database? Oh yeah, yeah. There's no database. There's no database. There's no database. I should probably delete that file, but I'll do it later. So we have routes, and then the routes called we have the index file. So get blockchain, return 100. Okay, module that exports blockchain. So we have a controller. Okay, I'm just gonna do that. We have controller. Okay, so I'm not used to coding with large text, with a large text, with a large font, text, text, whatever. Okay, so we have routes aggregate, the blockchain. Oh, yeah, interesting, broken. Oh, get blockchain is broken. Okay, now we aggregate transaction, so we can get the transaction. Aggregate mine address mine solution. So as you guys can see, this is kind of like a makeshift um, server makeshift what makeshift blockchain. Oh, okay, so I really messed it up. All right, so we have transactions. We get all the transactions. This is heuristic, yeah, by the way. For you guys that don't know, um, um, yeah. So these are the routes also connected to the controllers. The controllers are what actually do things. So we call the controllers these things. They get blockchains a function, but this one is over here. Um, oh, okay. And then yeah, so we have blockchains that get all transactions, which links to this file function. What is it? Function. This is a function. Do I call this a function? A function that is connected to, or yeah, that we export from this directory, controller.index. Also, we actually have one file. Okay, guys, I haven't coded this project in such a long time. I'm actually learning it as I am making a video about it, and I'm having to. Um, and I'm also eating my girlfriend's biscuits. She left them here. Okay, so okay, so it seems that I'm creating three transactions here. This is kind of like demo transactions. So seems like I have my wallet address here. So oh, my wallet address I think is my wallet address is the address of the blockchain basically. So so we have a blockchain and then you have the main address. And in the main address, we're creating a transaction. So I'm paying Paul 100 grand for 100, yeah, 100 grand because that's the currency that I use, or $100 if you're from the States or Canada or wherever else where we use dollars. Um, so we create the transactions in TX1. TX1, we have to sign the transaction with my key, which uh, you know, yeah, the private key. Private key. My wallet address is private key. We need to sign if I remember correctly. Um, and then what else do we do? We go with the add transaction take one. Okay. We sign. Okay, we do the same procedure 3 times. Just trying to understand something. Okay. So basically, the two transactions that get added to the blockchain because I didn't write a function that adds this third block transaction. So and then we export the node. What is it? The node is the actual blockchain. Yes, node is the actual blockchain. Here it is. Then we export it. What was I doing here? I was running like a demo miner here, but I omitted that by commenting it out. Um, then we have this is the controller. So wait, let me see. Okay, so oh wait, okay wait, forgot a lot of things about this project, dude. But okay, so there's exports.mine, which yeah, mine. Um, I'm surprised. I'm not surprised, but I'm wondering why all these things are sitting outside. So to my understanding, these are just gonna run automatically, and exports.mine is being called by the routes. Let's say you're mining using desktop application. Uh, this is the controller that you'll be calling every time you mine. Um, Node.mine pending transaction client. Oh yeah, transactions client. I remember adding this client no no tag here because I was building this particularly for when a client like someone is using the API like the external um, uh, uh, application such as the desktop application called the blockchain. This is what's going to be called. But I had yeah, okay, cool. So this is what's going to be called. We're going to get the user's data, parameters is the person, the miner's address, the miner's solution. Okay, it's starting to make sense now. Okay. So I think how I designed this application because I remember building this ecosystem to be as easy to understand as possible. Basically, when a user mines, they start the application and what happens? So the blockchain is running. So you send transactions. So the blockchain is running, and then a user makes transactions, just like I did here. So there's let's say two transactions. Fine. Wait, let me see something. All right, there are two transactions that are created, and then a user needs to mine them. Now, when a user mines them, request the parameter, we get their address, they send over their address, and then they send over their solution for the block, right? And when they send over the solution, um, yeah, do some error checking, validation, and oh, we call mine pending transaction client, which is the model, right? Is it the model? Wait, what? Mine pending transaction client. This is a function. Yes, this is in blockchain. Yes, here it is. So method to send the block back to the user to start mining. Okay. It's an asynchronous function. Mine pending transactions client. Okay, so when transactions are created, they are sent to this array, which is called pending transactions. I think I have it up here, if I remember. Okay, so there's an array. Okay, here it is. Yeah, here it is. Here's the class. Pending transactions, an array. And mine pending. So when transaction is created, it sends to the pending transaction. And then when the user decides to mine at that point in time, if there are like 10 transactions inside the block, right? Then this is okay. So whatever amount of transactions there are, because I didn't set a limit to that or any of that. Mine pending transactions client, mine address. We take the address, we take their solution, uh, and then, okay, if the client queries with an empty string or now for the minor solution, then they just want the block to mine. Okay. Oh, okay. However, if they send both minor address and minor solution, then they think they have the solution. Okay, cool. So when an external or third party application sends only their minor address, or their wallet address, then they just want to mine, so they want to receive information. So, but then they want to receive information about the block so that they can take that information and mine. So they do that, and then they mine, and then once they send the information back to the server, once they find the solution, they're gonna want to send another request to the server and say, or to the blockchain and say, hey, here's the solution. We think we solved it, and then we send it back to the blockchain, and then the blockchain, if it gets both the solution and the minor address of the what of the blockchain of the block current block that is supposed to be mined, then yeah, so then we know that they're trying to solve the equation, and from there we're gonna reward them if they get it correct or not. So if minor solution dot link if it's now, or there's not if there's no minor solution, then we're returning this. So we're sending them the block. So it's JSON, right? We're sending them block, and we're sending them the difficulty. So it's just a JSON response that has two properties, a block and difficulty. You send them back. Otherwise, if they think they have the solution, so now they sent us both the minor address and the minor solution. Um, we, the blockchain, start to mine it. We mine it. We verify. So in a normal blockchain, what happens is that you have the detail, you have the block, and you're gonna try and mine it. You mine it. When you mine it, you have a solution. You're gonna send it back to the server, or the decentralized blockchain, and the blockchain. The different um, what are they called? Like different computers in the blockchain. I forgot the is it nodes. The different nodes in the blockchain. Uh, a few of them are gonna try and verify if you did get the solution right or not. And if you did, you're gonna get rewarded for that. So in this case, the blockchain, our blockchain, is the one that has to verify that. So it runs its calculation by itself, which is interesting because yeah, no, I didn't create this application in such a way that it can do multiple things at once. As you know, Node is single threaded, so basically processes are going to get blocked while it's doing this. Because if it's trying to calculate or running this process, that's trying to if it's also trying to mine the solution, then it can do other things, like it cannot accept transactions at that point in time, so it needs to wait I mean, it has to finish what it's doing before it can start accepting transactions and stuff. So that's interesting, and I feel like by building this writing the software the way I did, I've made a terrible mistake, but actually it's working to my advantage because a lot of things. Okay, so a lot of things. All right, wow, this is like I haven't coded this in such a long time that I legit feel like I'm excited. I'm excited to just go through this application again, just explore what I wrote, like code that I wrote like a long time ago. It's not really a long time ago. It's a couple months ago. Okay, so and by the way, some of this code, like probably 50% of the code in the blockchain, is not mine. It's code that I copied from the internet. Like 50% of this project currently is code that I got, mainly the blockchain, like mainly the block. I'm sure you guys have seen this somewhere on the internet. I mean, everyone that does a tutorial on YouTube or on the blog site does basically the same thing, whether it's in JavaScript, Java, or whatever, and the blockchain. Not everything though. There's a lot of stuff that I changed. Yeah, but the concept is what I copied. The concept is what I copied. But then there's a lot that I changed. But yeah, this okay. Yeah, okay. I'm just gonna get rid of that. So yeah, that's basically it. And then what happens? Gee, I forgot where I was. Where was I? Oh, I was in the controller. No, I was in the actual blockchain. Uh, things like add transaction and yeah, add transaction. I'm not gonna go through because this is standard. Yeah, okay. What was that? What was that? My pending transaction client. So if you there are similarities in the way I wrote the functions. Mine pending transactions. This is meant to be used by the blockchain. So as I told you, the client. Wait, wait, I'm crazy. Okay, so yeah, there's mine pending transaction client and then there's mine pending transactions. So mine pending transactions actually mine because remember the blockchain actually has to mine, but then mine pending transactions client sends data to the to the client if so and so is like that, but if so and so is not like that. For example, if we get both these addresses, then we get the information and then we compare it against ours. So here it is. So we mine our own, my mine, your mine, which is the minus solution that we got from them, and we just spit it out here. Minus solution. It's not necessary though, but it's good for now. For testing purposes, so since we're still in development mode, if mine equals your mine, if my mine, I know my mine is legitimate, but is your mine legitimate? If it is the case, then the block has been successfully mined, and we do all the usual stuff. So, um, yeah, we reward you. We're gonna reward you. As a result of my success, we tell you what your reward was. We put it here. So we add the transaction. We create the transaction. So you can create the transaction or you yeah, you get it. So yeah, and then add transaction is a function. Uh, Basic. Add transaction client is when the client or any other third-party software, I don't know how many transform repeaters, actually adds a transaction. So they want to make the transaction, check if it's valid or not, etc. There's a, yeah, all these things are standard. Everything else is standard in the blockchain. Um, let's see. Let's see what else is in the controller. I'm just gonna ignore the being commented out text. So export get address balance. Okay, get blockchain, get all transactions. Okay, so these are functions in the controller that I call in the routes. Like get blockchain, although it's broken. Yeah, I don't know what happened there. We'll check it out. Get all transactions. I know this works. This function works. I hope it does, but I'm sure it does. Yeah, actually it does. And I'm sure that these things here are transactions that are created. I'm not sure why I'm spitting out the date in which the transaction was created, but yeah, this was in development mode at the time, and I guess that's what I thought was more suitable. All right, so fine. I get all trans. Okay, good, cool, 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 cool. As you can see, it's just like this API. All right, so I kind of understand the gist of what the application is all about now. I'm just gonna freaking delete this database thing because there isn't supposed to be a database. There isn't supposed to be a database. I know that there is there is a database in blockchains. In blockchains, I forgot what type of database they use. Some sort of database to organize and manage stuff here and there. We are not gonna use a database for simplicity reasons. So I'm just gonna delete this folder. Yeah, so that's what I'm gonna do first. I'm just gonna I don't know what I'm doing now. Let's see. I'm just gonna warning LF will be replaced by control in this file will have its original line ending in your work directory. This file will have its original line ending in your work directory. I don't understand that. I don't understand that. I don't understand what that means. Wait, I'm just gonna commit and see what happens. Remove database folder get push. Okay. Okay, so my tea's gonna. So this is the I think the reason my pages are loading so slowly. Oh, actually I don't know. I was about to give a dumb reason why I think my pages are loading slowly, but um okay. Wait, why am I here? I'm supposed to be wait, why is okay, I don't know why my backend is handlebars in it. Oh, seems like I have some sort of documentation here. So yeah, as you can see, 1 minute ago, it has been uploaded. Created a release 2 November 2021. That's so long ago. Okay. Before you read further, this application is a makeshift blockchain not intended to be used in production or anywhere else except for learning purposes. So don't be too hard on how I built the chain and the entire ecosystem for that matter. Just read, learn, and make progress. Pull requests if you will. What does this ecosystem consist of? The server application, which is a mistake they typing error. Which is the project you are currently viewing? The website where okay, the mining tool. So oh yeah, guys. So if you guys really want to read about this, just go here and read. Just read everything here. What is the mining? How does the mining work? That's how it works. How many transactions per block? Yeah, kind of very interesting. Already I can see what my solution was because I remember I ran into this problem and I was like, oh shit, sheesh. I'm gonna have to because I know Bitcoin has like a maximum number of transactions that can go into a block, and once the number minimum number yeah, the maximum number of transactions reach that block. There's kind of a cutoff, and then that's the block. That's the block with the however many transactions that it has. Like, I don't know how many they are in the block, but yeah. And then from there, yeah, and then from there, yeah, that's how it works. But in my case, I think I found it a little bit difficult to do that because I thought that there's so much administration to this thing because I don't want to build a complicated system and end up having to sit here every freaking night and worrying about how I'm gonna like when am I gonna get the time to finish this project. So I'm just cutting corners wherever I can. Okay, so because I was thinking, okay, if I'm gonna do it the way that blockchain did it, Ethereum, um, sheesh. Okay, I don't remember what I was thinking at the time, but I remember if I chose this, I thought that this was the most feasible way to do it at the time. So I'm just gonna stick to whatever I'm doing. I'm not gonna change anything. So I'm just gonna read this. Currently, the amount varies. We do not add a timer that only loads a. We have not added a timer that only loads a new block after every 10 minutes, like Bitcoin. Huh. I'm not even sure that Bitcoin has a timer. I just think that they're number. I'm not. I don't even know. Maybe there is a timer, like for 10 minutes, and then however many transactions is what's going to be mined. But whatever. Instead, they could be as little as one to as many as a billion transactions because mining only happens when a third party node asks to mine the block. Oh, okay, great. So So what this system allows is that there could be a billion transactions, and it also allows that there could be one transaction. So whenever a transaction is created, so now I'm starting to think there might be problems with how I built the application or the ecosystem because I'm going to be running a Python script that is currently checking if it can mine, and if it can mine, it will mine. And mind you, there are 100 freaking users, right? Users that are looking to mine, Python users that are looking to mine, and they're always checking. Like it's a script that's always going to be running on the internet, so it's always checking if there are transactions to be mined. So if there are, it'll always try to mine them. So I'm just thinking, they're probably not going to be more than 5 or more than 10 transactions create mind good. I'm thinking that in every block there's probably going to be like one, two, three, up to 10 maybe maximum transactions per block because of exactly what I just said. But I'm not sure because I don't know. I'm also going to be running a script. I'm also running a script. So if you see here in the random automator, there's a script for minings and there's script for transactions. So this is a script that just automatically is a script that I'm gonna write that's just automatically gonna um, create transactions. As out of the 100 users, it's gonna choose a random user, two random users, right? One is gonna be the sender, one's gonna be the receiver, and the sender is gonna transfer a random value amount to that receiver. Um, if he has that amount. So, okay, first I'm gonna have to check if that user's I'm gonna have to check his balance if he has more, if he has an amount, that amount. If wow, okay, cool. I'm gonna have to check his balance and if that user has enough money or whatever amount he has. Let's say he has $100. I'm just gonna run a range between $1 and $100 in which that user can send to the other user, and then yeah, whatever amount I get from one to 100, I'm going to use that figure, and we're going to use that figure to send to the other party. Um, okay, that's how I'm going to do it. So okay, what I wanted to demonstrate by coming to this page is that we have two items here, two folders, mining and transactions. So the mining, oh sorry, the transactions, I'm going to be creating a lot of transactions randomly. and then we have minings. So at the same time, there's going to be, minings that are happening. Uh, so these processes will be running concurrently. I was thinking I should write convert it to a concurrent application where both these processes are running at the exact same time. But I thought, no, I don't know how I'm gonna do this. Basically, we'll just see. We'll figure it out. We'll figure it out. It's a bit complicated. A bit complicated. But okay. I had a fear that exactly what I explained, that there are gonna be a lot of minings. There are gonna be a lot more minings than there are transactions, and therefore there's not gonna be enough transactions to mine, or enough blocks to mine, since there are not enough transactions. But somehow I need to balance it all out and make sure oh make sure that we have enough transactions to mine. So, but yeah, that's basically it. So that's that. Yeah, this will obviously be a big issue and will be solved. So contribute and solve it yourself, lol. Yeah, no, you guys are more than welcome to contribute if you're into that type of thing, and I know a lot of you are. The users can create an account and log in. They can create a wallet where a public and a private key will be generated for them through the website. The system will encrypt the private keys before storing them in the backend. Users will be able to virtually add their bank card and purchase crypto on the platform website. Users will be able to send random note to other users via public key. If the user sends notes to a non-existing address, the coin will therefore be lost forever. Obviously, a user can decide to mine the crypto using C++ and Qt developed desktop application that they would need to install on their Windows computer. The application will only require that the user's public address, and all the rewards will be allocated to the particular address. If the user provides the wrong address, then the nodes generated will be lost forever. Obviously, with the generated nodes, the user can then transact with other users. Users can opt to sell their nodes on the platform and get cash in dollar as a result. I forgot that I had to, program all of that. Conversions and money allocations. When a user deposits money into the system, they choose to deposit in what currency they and choose the value. Example: Siko deposits 15 rand, or James deposit $1. Both are the same value and should both equally purchase one rand note. Assuming that's the value of the note at the time, and assuming that 1 rand is equal to $1 is equal to 15 rand. Um, when the user deposits, their balance will be shown on the system. However, they would still need to convert their dollar/rand to notes. Okay, the system will work just like how any normal system would. If a user decides to sell or buy their note, a charge will be made, and the website, will earn money. Why did I decide to write all of that? Because like that's a lot. That's a lot. This is an open source project. Any new ideas and additions are always welcome. This project should never be turned into a real platform that accepts real money, as it is not stable and has a lot of security risks. Obviously, I mean, guys, come on. I mean, obviously, there's a lot of security risks. Yeah. Hey. Okay. Cool. So that's basically the application overview. I think I'm gonna make coffee, and I'm just gonna start programming. I don't know exactly what I'm gonna start coding. Um, Probably the Randall automator. Just try and see if the blockchain works properly, and just try and figure out where where these things come from. Although I think they come from the transactions, and then you know convert these logs into like meaningful logs, and and write the automator and see where it goes. So yeah, 7 p.m. So I don't know what time I'm gonna sleep, but whatever time I decide to sleep, it's okay. Yeah, all right. Let me make coffee and I'll be back.